Hello, AP Psych. Welcome back to day 2 of our intelligence learning. Today, we are going to be on pages 5 through 5 of your best. Specifically, how can we look physically at the brain? This would be the biological side of our biopsychosocial approach. And we'll look at some common tests that we can give that measure intelligence and the different types of intelligence as well. Keep in mind, again, that we need to worry about reification as we move through this process. In other words, you can't assign a number to an abstract concept and have it work out perfectly. So all of these things that we're about to look at are flawed in some way. They don't measure the full range of intelligence in a person. Here we go. So how do we measure intelligence overall? There's a few different ways of doing this. To start off, we'll look at brain properties a little bit. If you look at a brain, there is actually some correlation literally between the size of the brain and the intelligence level. For example, if you were to hold up a human's brain next to a monkey's brain, the human's brain is larger than the monkey, and particularly in the cerebral cortex, with the 4 lobes, the outsider part. Remember, that's the part that makes us human. That part is especially overdeveloped in humans relative to others. If you compared a monkey to a mouse, the monkey's brain is obviously much larger. If you compared a monkey to a whale, a 50-foot-long whale, the monkey's brain is actually larger because the monkey is more advanced intellectually than the whale. So there is some correlation, even looking at differences between people, between brain size and intelligence, especially in the frontal and parietal lobes. If you have a larger frontal lobe and a larger parietal lobe, you are more likely to be a little bit smarter, to score higher, I should say, on intelligence tests. At the same time, highly educated people tend to have more synapses than less educated people. Remember, synapses are those gaps between neurons. Highly educated people tend to have thicker, more intricate networks of neurons in their brains than less educated people. As you move through life, your brain forges connections based on the learning that you experience. So it would make sense then that people with more learning have more connections and thus more synapses. One other thing is the concept of gray matter versus white matter. Gray matter is the cell body of a neuron. If you literally cut open a brain, cell bodies look gray under a microscope. This is opposed to white matter, which isn't on this slide, but white matter is neuron, axon, and dendrites. People who score highly on intelligence tests tend to have more gray matter in brain areas involved with memory, attention, and language. And again, that gray matter is the neuron cell bodies, not axons or dendrites. Similar, so looking at some other stuff related to the brain specifically, there is some correlation between intelligence test scores and the speed at which you perceive sensory info. So in other words, as you look at this picture of a brain running on a treadmill, the higher your score on an intelligence test, literally the quicker, it's more likely at least, that signal is moving from your eye up into your brain and being processed by your brain quicker than in someone who scores less well. Test. Impulses are moving our brain. The brain is associated with memory and with language, and those are different parts of the brain. Those two parts of the brain send signals back and forth to each other more quickly in someone who scores higher on an intelligence test. Let's talk a little bit about intelligence tests specifically. This is getting into the quantifiable aspect of intelligence tests. When we talk about intelligence tests, we're going to talk in general about mental age. Mental age is the level of performance on tests normally associated with people of a certain age. So like my example here, if you're given an intelligence test and you score an 8, that would say that you have the average intelligence of an 8-year-old. This is the most simple version. Intelligence test scores are actually more complicated than this. But in its most simple version, If you score an 8, you have the intelligence of an average 8-year-old. If you score a 15, you have the intelligence of an average 15-year-old. And again, no test actually exists that uses that exact lineup, but tests are meant to correlate between score and an average mental age, average achievement level. This was originally developed by an education minister in France whose name was Alfred Binet. Binet's concepts ended up being so influential that they're still used today, actually, in what is called Stanford-Binet tests. And those are the most common types of IQ tests that are in existence. We'll talk about a little bit more about that in a second. But Binet was basically interested in taking children, giving them a test, and then using that test to identify how mentally developed the children were. If you were 5 and you scored an 8, well, then you were super smart. If you were 8 and scored a 5, your mental age was an issue. You needed extra help in school, for example. Binet's ideas eventually developed into what is called IQ. Binet was really focused on school children because he was an education minister. Terman thought, no, we need to expand this to all adults. So Terman's range of scores goes from 0, which is like a newborn who knows nothing, to a genius adult. And again, IQ was trying to calculate mental age. So Terman would give people tests and then determine their intelligence quotient as a result. And intelligence quotient, which we refer to and I will refer to as IQ, is the ratio of your mental age to your actual chronological age. And the average IQ score is 100, which would be a perfect ratio. So in other words, your ratio, if you score like the average score of a senior in high school and you are a senior in high school, your IQ would be 100. And this is the formula for those math people who like to see it in front of you right now. IQ is mental age, determined by a test, divided by chronological age, just how old you are, and then you multiply that whole thing times 100. And again, most intelligence test scores don't exist in a vacuum. They are meant to measure your intelligence relative to other people. The ACT measures your intelligence relative to other people, not by itself. Today, we don't usually use the Mensa is a group of, they call themselves geniuses, and you can get into it simply by passing a test, and it's more or less an IQ test. Then if you score super high on that test, past a certain benchmark, Mensa invites you into your organization, and you get to say, I'm a Mensa member, and everyone will think you are a genius as a result. That is an example of one of these two types of tests, achievement and aptitude. Achievement tests assess what you have An example of an achievement test would be the most common intelligence test. This is just a quick fact you have to know for our exam, is the Wechsler Adult Intelligence Test, or both verbal and nonverbal sections, things that deal with both like spatial reasoning and also words problem solving. This is an example, some sample questions from the Wechsler test. And you can see they've got a verbal section right here. What day is Independence Day? That's basically just what you know already, a basic measure of intelligence. Here, though, we have performance as a nonverbal portion. You're trying to solve a problem given a picture. This is more problem solving, this is more predictive type stuff, and you can see some of that on the rest of this as well. So that wraps up today's video. Again, your